In video 5.6.6, Max and Min explored the features of the different types of triangles, including the number and size of their sides and interior angles, which triangles are regular or irregular, the translation, reflection, rotation and enlargement of triangles, and line, as well as rotational symmetry. After presenting their excellent report on triangles, the twins made a similar study of quadrilaterals. In video 3.6.6, Max and Min had learnt a lot about quadrilaterals, which are closed 2D shapes with 4 straight sides and 4 interior angles. There are very many differently shaped quadrilaterals, but the twins were mostly interested in 4 of the special ones. Max reminded his sister about it. So Min, a parallelogram is a quadrilateral which has opposite sides of equal length and also parallel. Remember, parallel lines are lines that will never meet, no matter how long they stretch. The rectangle is a parallelogram with right angles at all 4 vertices. The rhombus is a parallelogram with all sides of equal length. And the square is a rhombus with right angles at all 4 vertices. Yes, Max, a square is a rhombus, and it can also be described as a parallelogram and a rectangle, added Min. And if you look at parallelograms other than rectangular ones, you can see that they all have one pair of opposite acute angles and one pair of opposite obtuse angles. That's correct, Min. And now that we know that regular shapes are those that have all their sides and angles equal, we can say that squares are regular shapes and all the other quadrilaterals are irregular shapes. The twins got out some grid paper and quickly sketched the 4 quadrilaterals they were discussing. They knew that they could translate them, reflect them, rotate them, and enlarge them, just like they had done with triangles in video 5.6.6. They then started drawing lines of symmetry on each of their 4 special quadrilaterals. So Max, we can see that the square can be folded over a line to create equal matching halves in 4 different ways. So it has 4 lines of symmetry. Yes, Min. And the rectangle has just these 2 lines of symmetry. If we draw a diagonal on a rectangle like this, it does create 2 halves. However, if we actually fold the rectangle over this diagonal line, the halves don't match. That is, they don't sit exactly over each other. So this diagonal is not a line of symmetry. That's correct, Max. A line of symmetry is just like a line of reflection, where the 2 halves are reflected either side of the line. Now, with the rhombus, if we turn it to look like a diamond, it becomes easier to see that it also has 2 lines of symmetry. But Max, what do you think about this longer parallelogram? Well, Min, I have looked at this before. I actually cut one out of paper and started folding it, and found that it doesn't have any lines of symmetry. Hey, let's cut out all 4 of these special quadrilaterals now and see if they have any rotational symmetry. So the twins cut the shapes out of coloured paper and rotated each one around their centre, just like they had with the triangles in video 5.6.6. They found that the square has order 4 rotational symmetry, while the parallelogram, the rectangle, and the rhombus all have order 2 rotational symmetry. Why don't you cut out these 4 special quadrilaterals to fold and demonstrate their lines of symmetry, then rotate them around their centers to show any rotational symmetry? Now you can watch this video again or try the quiz and look at the chart that comes with this video.